Applications with radical equations. Helen drops a ball from 25 feet above the lake. The formula is given by this equation, and it describes the time. So t is time in seconds. The ball is h feet above the water. Question: how long is the ball in the air when the ball is at 16 feet? So the question of how long is a question of t. So we are solving for t, which means when the ball is at 16 feet, that is the value of h. So we're going to take our equation, t equals 1/4 root 25 minus 16. All right, so this one is easy to solve. It's just an evaluation of 25 minus 16, which is 9. Root 9 is 3. 3 times 1/4 is 3/4, or 0.75 seconds. So the ball is only in the air for 0.75 seconds when it is at 16 feet. How many feet above the water will the ball be after 1 second? So the question is how many feet? Well, feet is h, and h is inside the radical. And so we're going to set t equal to 1. And we're going to solve for h. And so we're going to follow the steps to solve a radical equation. We're going to isolate the radical first. So that means that we're going to multiply both sides by 4. In multiplying both sides by 4, we end up with 4 equals, and 4 times 1/4 is 1, root 25 minus h. And so now we have isolated the radical. We're going to square both sides. 16 equals 25 minus h, and therefore h is 9, because 25 minus 9 is 16. And that is an application of a word problem that utilizes a square root equation. All right, the last type of solving radical equations are when we square both sides and the result is either a quadratic or a polynomial. In these particular equations, you are going to want to check your solutions to make sure that you don't have any that are called extraneous. Extraneous solutions are apparent when you solve, but when you plug them back in, they possibly don't make the equation true. All right, so we're going to begin by squaring both sides in number 7. Now, when you square the left side, you just undo the square root. That's 7x plus 15. But when you square the right side, you write it twice, because to square a binomial means to write it twice. Then you do FOIL, or double distributing. So that's x squared plus 1x plus 1x plus 1. X squared plus 2x plus 1. Subtract the 7 from the 2, and it's going to be minus 5x. Subtract the 15 from the 1, and it's going to be minus 14. And now you see we have a quadratic equation that needs to be factored. So two numbers that multiply to be a negative 14 and add to be a negative 5. So subtract 7 and add 2. That's going to give me a product of negative 14 and a sum of negative 5. Set each one equal to 0. And now we have our two apparent solutions, x equals 7 and x equals negative 2. Now comes the part where you have to plug each one back in separately and see if they make the equation true. So if I plug in 7 times 7 is 49, plus 15 is 64. Square root of 64 is 8. If I plug in 7 on the right side, 7 plus 1 is 8. I get 8 equals 8, and so this one checks. So I'm going to go ahead and put a box around that one. Now I'm going to test negative 2. Negative 2 times 7 is negative 14, plus 15 is 1. The square root of 1 is 1. Plugging in -2 on the right side, -2 plus 1 is -1. -1 does not equal 1, and so therefore this is an extraneous solution. And that is the way you provide the solutions. You put a box or you circle the one that is actually a solution, or maybe both are, and you X out the extraneous. So think about extraneous starts with an X, so X out the extraneous. All right, let's try that again. Same type of procedure, square both sides. We're going to get 10x plus 9 equals x plus 3 times x plus 3. 10x plus 9, x squared, plus 3x plus 3x plus 6x plus 9. Please feel free to do some of those steps in your head. 0 equals x squared, subtract the 10 minus 4x, subtract the 9 plus 0. Now it only has two terms, and so to factor, we're going to do a GCF of x, leaving us with x minus 4. So GCF, setting them equal to 0. We have our two potential solutions, 0 and 4. Let's test them. If I plug in 0, I get the square root of 9, which is 3 on the left. If I plug in 0 on the right, I get 3. So that one checks. If I plug in 4, I get square root of 49, which is 7 on the left, and I get 7 on the right. So here it is an example where both solutions are actual solutions of the original equation. All right, last one. We're going to square both sides, but on the left, we can't isolate that radical. So there's a square root of x plus 6, but then there's a minus 2. How do we square that? Well, we do what I said in the previous ones. We write it twice. So square root of x plus 6 minus 2, square root of x plus 6 minus 2 equals, and then of course on the other side it's easy, it's just x minus 2. All right, if you multiply the first two radicals, that's essentially multiplying it by itself, and so you get x plus 6. If you multiply square root of x plus 6 times -2, you get minus 2 times the square root of x plus 6. And then you get it again, minus 2 times the square root of x plus 6, and then you get plus 4. Let's combine some like terms. We have x plus 6 plus 4, so that's going to be x plus 10 minus 4 times the quantity x plus 6 in square root. Those are like terms. These are like radicals, like terms, okay? Equals x minus 2. All right, now let's isolate the radical so that we can square both sides. So I'm going to subtract x from both sides, and I'm going to subtract 10 from both sides. Over here I get minus 4 times the square root of x plus 6, and over here I get negative 12. So we subtracted the x and we subtracted the 10. Still one more step to isolate the variable or the radical. Divide by -4 and you get the square root of x plus 6 equals 3. Square both sides again. So this one is extra steps. We squared both sides and then we had to do it again. X plus 6 equals 9. X equals 3. All right, so we did all that work. Now let's go back and see if it makes the equation true. All right, so I plug it in on the left. 3 plus 6 is 9. Square root of 9 is 3. 3 minus 2 is 1. Plugging it in on the right, 3 minus 2 is 1. Square root of 1 is 1. And so it checks. And so that's my solution.